I'm audible, Sai Teja?
Yes, sir.
Yeah, fine. Okay, today we'll see the last class of the first unit, and then I will share these things to all of you. You can prepare, and we'll start next. Yeah, tomorrow we have some inspection, so you can prepare this unit. I will share this unit, and Monday I will start the second unit. Yeah. In this classification of meta-heuristic techniques, there is a broad classifications as a single solution based because many classifications are there. I will start with this and then we'll move on to that part as well. Now we can see here there is a single solution based algorithm and population based algorithm. So these are the broad classification even as per our syllabus also like this. Classification of meta-heuristic techniques and even there is a single solution based and population based algorithms. So in that we can see the local and neighborhood searching algorithm. For that, there is a something tabu search algorithm, and then simulated annealing algorithm. These are all the old, of course, and local search and iterated local search. These are the related to neighborhood search algorithms or local or neighborhood search algorithms. And there is a population based again. We have two categories in a population base because many of all optimization algorithms nowadays is a we are using population based algorithms on only. We have genetic algorithm. This is for the second unit anyhow. Then non NSGA2, it is very popular in the case of multi-objective optimization. That is a non-dominated sorting genetic algorithm 2. So non-dominated sorting genetic algorithm 2. This is the popular algorithm, of course. So NRGA. So then real coded genetic algorithm. Then DE, differential evaluation and base. Like this, we have many type of algorithms in the evolutionary algorithm. I quoted only few. And then SWAM intelligence algorithm. This is also one of the popular based algorithms. Again, here so many algorithms come into the picture. That is a PSO and firefly algorithm, and then ant colony algorithm, and honeybees algorithm, or artificial bee colony algorithm, that is ABC, and bat algorithm. Like that, we have still cuckoo search algorithm. This also you can use it, cuckoo search algorithm. Like that, it is related to the spam intelligence. As I said, no, SWAM is nothing but a group of agents. The agent may be person or animal or insect, like that. So instead of doing one person, they're doing group and they can exchange their information and to get as a better solution fashion. So like that, we'll get it as a population based algorithms. Now, we can see again the classification in the different kind of representation. As per the previous one, I shown you know single solution based algorithm and population based algorithm. All these things I made it as a one classification table so that it is easy for you to represent in exam point of view also. In the population based algorithms, again, I divided as a evolutionary algorithm and spam intelligence algorithm like that. And single solution is the local or neighborhood search. All these things are merged here. Now we can see here there is a spam based is there, evolutionary based and physics based algorithms, natural inspired algorithms, biosimulated algorithms like this. I classified. You can see one by one. There is a first category. Like this, we have five categories. I, I divided this classification. In the first category, bio stimulated algorithms. These are comes under gray wolf optimization. Nowadays, in the literature, if we see, Gray wolf optimization algorithm is something more papers we can see. So the researchers are using gray wolf optimization algorithm. And another one is spotted hyena optimization. My paper also there in that spotted hyena optimization. Like that, there is a dendritic cell algorithm, DCA algorithm. Another one is a artificial immune system. That is a immune system. There is a AIS, we call it as a, and like this is respected to the biostimulated algorithms. Similarly, natural inspired algorithms. There is a BAT algorithm. This also a bit old only, but many people are using still. Then cuckoo search algorithm. I used this algorithm also in one of my research work. And cuckoo search algorithm, in invoice weed optimization algorithm, invasive weed optimization algorithm, and then flower pollination algorithms, like this FPA. This is related to the natural inspired algorithms, and physics based algorithms also is there. Harmony search algorithm, because it is completely how when you the harmony, if we are using the how waves is going to be related to that, we will get it as some equations, the physical physics related equations. Anyhow, for all these things, algorithms we are developing as a mathematical equations only. From the mathematical equations we are going to derive, or you can say that optimize our problem. In that the equation may be different, but the solution, if we apply all kind of algorithms, we can easily identify which one is going to be better in terms of different kind of algorithms, different nature. You can see whether it is in the calculation part is faster, or more calculation is there, or number of iterations, how many iterations it is taking to reach the optimal value. That kind of things we are able to develop these kind of algorithms. Then evolutionary algorithms, genetic algorithms. That's what physics-based harmony search algorithm, gravitational search algorithm, simulated annealing, black hole algorithm. These are all related to gravitational search. Also, it is a okay good algorithm. But what we can do in the nowadays researchers, they are not using only one kind of what you call it as only one algorithm. They are doing as a mixing of algorithms. What is mixing of algorithms here? Mm, One thing we can say that there is a what you call it as advantages of the existing algorithms they will take, but in each algorithm they have their own disadvantage also. After identifying the what we call it as advantages in that particular algorithm. We are mixing the algorithms to hybridizing. The advantages of these two algorithms will apply for the our optimization problem, or to solve our problem, uh, so that it will perform better than individual algorithm. That's what the literature says. So that's why in my case also I used cuckoo search algorithm and then genetic algorithm. Then I call it as a hybrid cuckoo search algorithm. And other sometimes I used I think firefly algorithms I used, and along with the genetic algorithm like that, hybrid firefly algorithm. Or you can use any kind of algorithms with mixing of better algorithms. Then we can understand why we need to mix that. What is the advantage by adding this? That kind of things we need to identify before hybridizing these algorithms. Now, another one is the evolutionary algorithms. In these evolutionary algorithms, only we are our subject. That's why we used this genetic algorithm, and then differential evaluation. Another one is a genetic programming, and then evolutionary programming, and SPAM is the what we call it as a latest techniques or meta heuristic algorithms. This also incorporated in syllabus particle spam optimization and anti-colony optimization and fish spam algorithms and artificial bee colony. So these are all the algorithms we can use to get our optimal solution in the with less number of iterations, with the minimum object. We can say that it starts with the minimum point, and then it has to get to optimal value with a lesser time. So all these things and how the iteration wise variation, these things we can easily identify how it is going to be generated. So these are the classification. Then I will explain category wise bio-inspired algorithm, natural inspired algorithm, physics based algorithm, evaluationary spam, all these things, some points that for your examination point of view. Now you can see the first category is a biosimulated meta heuristic optimization algorithm. So that is the biosimulated algorithms. We can see here it is based on the foregoing or hunting. Normally, you can see that hunting behavior of the wildlife animals and sea creates. And some recent development population inspired algorithm is a gray wolf optimization algorithm. Nowadays, they are using more and more in that. And another kind of algorithms are spotted hyena and dendritic cell algorithms and artificial immune system. All this comes under the first category or biostimulated meta-heuristic algorithms. All these meta-heuristic algorithms have their own substantial ability to apply the premium efforts and find the optimal solution. So they have their own ability, but depends on algorithm. All the performance may not be the same. You can apply for one problem, spotted hyena, and same problem if you apply DCA or artificial immune system, the results may not be same results because these all heuristic algorithm continuously results is going to be vary. Because in this operation lot of random variables will be there. In that case what we can do is we make use of the data repeatedly. The every time the random value is going to be changed. That is the reason we can say that very answers will be different. And second category, it is a natural inspired optimization algorithm. So there is example for natural inspired, as I mentioned, BAT algorithm, Cuckoo search algorithm, and then IWO algorithms and FPA algorithms. Like there is a different kinds of these algorithms based on natural systems. That's why we call it as a natural inspired optimization algorithm. And third category, meta heuristic techniques is a physics based. As I mentioned, physics based algorithms. So inspired by the physical rules. We can also say this category is different from the SWAM-based algorithms. Mm, there is a search agents are communicating and there is a steering from one point to another due to physical rules. And some population algorithms are harmony search algorithms, and then BHO algorithm, then SCA, that means simulated annealing algorithm, and GSC, gravitational search algorithm. These are the some kind of the meta heuristic with the physical in nature. And fourth one is a evolutionary meta heuristic algorithm. It is based on the natural selection process concept. So how the natural selection, we can try to continue building on a fitness measured in their environment and applies to best effort to get the best optimal solution in the search space. So whatever in the search space, we are going to identify which one is the minimum value or a best agent, or you can say that best person need to identify using this kind of algorithms. This method has no idea about their adaptive nature and fitness, but some kind of algorithms you can see there is a recently developed evaluation based algorithms, differential algorithm, genetic algorithm, and evolutionary programming. So these are the some kind of what you can say that evolutionary algorithms. Last category is a spam based, which is based on the mutual behavior of insects. So here, this is all in general, all related to insect only. Like you can see ant, and that will change their information based on their no behavior. They're going to solve the problem. So based on the mutual behavior of insects, you can see that particles and various societal um, creatures. So artificial bee colony, this is one of the algorithm. This is also popular algorithm in your you can use this kind of algorithm to solve the problem after knowing the genetic algorithm and then differential evaluation algorithm and PSO algorithm. Same kind of this type of algorithm we can able to use. And then fish spam algorithms, particle spam optimization, ant colony optimization. So these are the some of the popular based algorithms. And you can see the advantages of SWAM algorithm. Once if you use SWAM algorithm, what are the advantages we can highlight? As a less number of parameters to adjust themselves. So whatever the parameters is there, we are using to solve that problem. Sometimes by iterative process or in the evaluation process, the parameters is going to be adjusted themselves. It does not have a substantial number of operative agents, and it collects different facts about their such space till the last iteration. So in the first iteration, you may get some information. That information is going to be exchanged the other agents. After that, again the process will start. Again, you will get some information that also will share among the agents. So that what will happen, whether they are going in the right direction or not, we can easily suppose. Let assume that four members want to go to some other building randomly, then preferably what they will expect it has to go with less distance travel and less cost. Like that, we may have as a different objectives or maybe some more constraints also. They all four members are moving randomly. Then after one point of time, they can exchange their information. So what is your location and where it is the optimal location is there, whether you are moving towards the optimal value or not. Like that, once if you able to exchange that information based on the best solution and who is going in the right direction, then others also will follow in that direction, so that again after some moves they can exchange their information. So like this, by exchanging the information to each other, it is easy for them to reach the best solution or optimal solution with a lesser time. That is the kind of SWAM intelligence is going to be easy to implement and simulate. And you can see these two things, whatever I explained, that is related to classification. After that, some more points we'll write based on this. Anyhow, that points also you can make use of the evaluationary algorithm, SWAM intelligence, like that local or neighborhood such parameters. You can write separately also. but I have given these two as a headings because it is mentioned in syllabus. The questions may ask as per the syllabus. They may ask you write a short note on single solution based and population based algorithms. So you can just elaborate these 2 points. That is sufficient. Now, single solution based and population based algorithms, you can see the single solution perform local search process by employing a single candidate solution. So trying to improve the solution in its neighborhood. So that is the kind of single solution algorithm. But whereas in the population based algorithms, such process by maintaining the multiple solution located in the different points of a such space. That's what the different you can see single solution, then population based algorithms. However, the main drawback of single solution is that global optima may not reach and it may get stuck in the local optima. Because as I mentioned in the optima in the last class, one of the slides, there is a difference between local optima and global optima. So local in the each iteration, whatever we are going to get that what you call it as a solution, that itself is treated as a local optima. But the global optima, all the agents by comparing the all the agents, we can able to identify which one is the best solution, that we call it as a global optimum. But it is a local search process. There is sometimes there is a fail to reach in the global optima. Whereas in the population based algorithms, so several starting points that maintain the diversity of the solution globally, because that is only the one here. As I mentioned, the second point, such process will maintain multiple solutions so that this starting point is maintain diversity of the solution globally in such a space, and results are better exploring during the search process. The single solution based algorithms are those in which solution is randomly generated and improved until the optimal solution is obtained. So for all these spam intelligence, normally, for that matter, all optimization algorithms, first step itself is a common for all. What we can do is we are going to generate a random solution. Suppose I want to move some step, we will go for randomly. Then we will check it whether our step is correctly correct direction or not with respect to each other. That is the kind of the problem here. That's what we can say that the solution is randomly generated first. And whereas population based algorithms are those in which solutions are randomly generated in a search space. Solution values are updated during iteration until the best solution is reached. That's what here that every iteration they will change, as I said, and their even the local optima value also going to be modified. Suppose that agent value may not be as a global optima, or maybe is the local. For this exam point of view, if I explain, that may be clear for you. Suppose first attempt you did something, you wrote exam, then you have as a 1 marks. Let it be as a, your percentage may be 70%. Other guy may be 80%. Some other may be 90%, like that. And who is having the global optima, who is having as highest percentage, he may be the best. Let it be is the global optima. Then after that, there is a some revision or maybe after training, and he wrote exam once again or betterment exam. Then the individual marks may be as a local optima. And after that, the second time, if he wrote the exam, their marks may be better. Instead of 70 marks, he may get 75 marks. But that is not become as a global optima. Same guy, he is further maybe improved 1 or 2 marks. and is still is a global optimum. But local optima, this guy individually they may be performed well, but they may not be reach again to the global optima. But individual optima is going to be vary. Instead of 70 marks, now he scored 75. Then the still it is a local optima only, but is replace that value 72 to or 70 to 75 like that. That's what is spam is going to be. And single solution algorithms may trap into local optima, which may prevent us to find the global optima. Reforms only one solution, which randomly generated for the given problem. So on the other hand, population-based algorithms have a inherent ability in the local optima. Mm, Due to this, nowadays population-based algorithms have gained the attention of many researchers. But this type of comparison also you can write. Sometimes if they ask compare single solution-based algorithms and population-based algorithm, this point also will suit. Or write a short note on single solution and population-based algorithms also you can write. The categorization of population-based algorithms is done on the basis of theory of evaluation algorithm, physics laws algorithm, swarm intelligence in practice, and biological behavior inspired algorithms. So these we can use it. Evaluation algorithms inspired by the evolutionary process, such as reproduction, mutation, recombination, and selection. So these are the terminology we in the case of evolutionary algorithm: reproduction, mutation, recombination, and selection. These algorithms are based on the survival fitness of candidate in a population for a given environment. Now, the physical laws based algorithms are inspired by the physical processes according to some physics rules such as gravitational force, electromagnetic force, inertia force, and then heating and cooling of materials like that. Swarm intelligence based algorithms are inspired by the collective intelligence of swarms. In that, we have as a different kind of algorithms, genetic algorithms, that is GA and ES and the DE, and biographical inspired algorithms also there, and spam optimization or particle spam optimization, cookie search algorithms like this, and well-known algorithms of spam in the particle spam optimization, PHO also. Social behavior of the fish schooling and bird flocking. So this kind of algorithms is comes under the swarm intelligence. Particle can move around the search space and update the current positions with respect to the global pest solution. After that, it is again will move. There is a velocity updation and then position updation. Both is going to be happen. So with some velocity, if you are moving, then automatically a new position has to be updated. So that from their point onwards, what is the uh, distance or near place to the what you call it as a objective function or a agent or the results part or optimal value. And evaluation algorithms are most well-known, traditional and established algorithm between the natural inspired algorithm, inspired from the biological environment in nature also. Then there is past years evaluation algorithms are extensively used for solving various specializations in the real-time applications also they are using. The word evolutionary algorithm used to define collection of optimization techniques that simulate the nature biological evaluation and the social behavior of living space. Then DE, ES, and GA, and the genetic programming, all these things I already mentioned. And then spam intelligence is the field of studying and design effective computational methods to solve problems using behavior of real world such as fish, bird, and ants, all these things related to the SWAM. SWAM intelligence is a part of artificial intelligence only, the global framework, and is several homogeneous agents will be there, which interacts with each other. That's what I am repeatedly telling. All these agents is interacting each other, and using the audio or visual tools, and honeybees communicate by words dance. All these things will happen. There is a indirect communication is reflect as a stigmary. That means a mechanism of spontaneous indirect coordination between agents. So that can again coordinate with each other. Then Grass first introduced the concept segment stigmary. That means there is a spontaneous indirect coordination process when the insect make changes in the environment around. So when coordinate each other, these insects is going to set their own values, or they can take decisions based on that information. All these things. That's what ant colony will do that, and other insect respond to the change in the adapt themselves to the new environment, such as ant colonies. When ant deposits the phenomena in the way to the food, so that's what it is keep on releasing something phenomena, mm, that will sense the other ant, it will move in the same line, and they have, you can see in houses when they are moving the chain link, they can communicate each other and leads other ant to follow. And that's the path. The example of swarm intelligence are ant colony optimization, artificial bee colony, particle spam, cat spam, and gravitational search and bat algorithms. So these are the things. And some properties of spam intelligence systems, we can see it is composed of many individuals. That's what the spam intelligence is a mention. It is a spam itself as a group of agents. It can composed, and the individuals are relatively homogeneous. Then the interactions among the individuals are based on the simple behavior rules that exploit only local information. The individual exchange directly or indirectly via the environment, and overall behavior of the system results from the interactions of the individuals with each other and with their environment. That is the group of behavior self-organized. And last one, there is a behavior of each individual of the swarm is described in a probabilistic terms. Each individual has a stochastic behavior. It depends on his local things. Then we can see some advantages of swarm intelligence and challenges also. The advantages are robustness. These are the some major advantages I mentioned here. These algorithms are highly robust to errors and failures. And SWAM, each individual agent work independently as per the previous characteristics also I mentioned. Overall performance of the system not affected by the failure of any individual agent. Now, suppose one agent may be fail, but we can observe because any search they are exchanging the information, even one of the agent performance also is poor or is less, then the system performance will not affect much. Scalability. These algorithms are scalable, meaning that they can easily handle large and complex problems also. So one is robustness, another one is scalability, and then adaptability. Highly adaptable to changing environment and situations. Based on the environment and situation, these algorithms is going to be highly adaptable. As environment changes, spam can adjust and adapt behavior accordingly. This also characteristics, because of that characteristics it's happened. And diversity are inherently diverse and meaning that they can handle a wide range of problems and situations. So these are the some of the advantages of intelligence. Another one, you can see the challenges of spam intelligence. There is a coordination. The major challenge in the spam intelligence is the coordination. The spam to function effectively, each agent must able to communicate and coordinate with others. This is what the major challenge. Without the coordination, the spam intelligence itself has a failure. So we need to do the lot of coordination and communication to each other. This is the major challenge. And complexity, because high complex problems we need to solve. Computational and power computational process also is heavy computational process is involved. For that, power and resources also required. Lack of control, there is a difficult to control, and the behavior of the spam is emergent, and can be unpredictable. Sometimes this cannot predict the spam behavior. All these things may change based on the environment. They can adjust, but that is also we need to take challenge to make it in the proper way. Communication overhead. Communication overhead can be major challenge in the swam intelligence. Effectively, each agent must communicate with each other in the system. Then SI is a swam intelligence has its advantages and challenges. As I mentioned, both advantages and challenges. But careful planning and implementation, this swam intelligence highly effective approach for solving, especially for the complex problem like nonlinear problems in what you call it as in the case of power system problems related. So these are the major advantages and challenges. We'll see some applications also in swarm intelligence will use in the optimization and the prediction process. Robotics also will use image and signal processing. As I mentioned, these applications are not limited. Is many more applications are there. You can use this intelligence techniques for optimization problems, and so this is the end of first unit. And I will share this today or tomorrow. You can prepare this tomorrow class, and after that I will start the second unit. Second unit onwards, it is very interesting, and we can solve. It will be useful for your projects also. Once if we are aware this optimization algorithm and machine learning, make use of both, and you can solve using optimization algorithms on the problem, and you can use machine learning algorithms, compare the results. That itself as a project like that. We can easily, what you can do is get the solutions based on the these comparisons, so that you can get it as a project. You can do it by your own. Even a lot of data sets, I shared this video links of workshop also. They made use of data sets. Using that, they can predict our what you call it as forecasting, or you can say that the fault also they can find, or they can what type of fault it will be, and then what is the price in future prediction, and what is the load forecasting. All kind of these things is a advantage, or you can say that applications we can use it using machine learning. Similar solution, any problem you can make use of optimization algorithm. You can apply this spam techniques to particular problem. We can easily solve that kind of. We can get it as a mini project and main projects and all. We can use this kind of things. Especially for mini project, a lot of algorithms we solved, that you can write a Python programming, and you can take as a data sets, and you can elaborate it, and you can publish the conference paper or journal paper like that. So we'll see that. And in the next class, we'll start the genetic algorithm. Okay, thank you all. If you have any doubt, you can ask me. Otherwise, you can leave.